So once again, welcome to the lecture number 7 of the deep learning course. In this session, we are going to talk about the perceptron, which is the first initial basic building block of the neural network based systems. And by going into this lecture, many exciting things are going to be started now onwards. We are going to see about the perceptron, that what they are, what is their idea, and we are also going to see that what is the method to train them. And you know that training means essentially means that finding out the right kind of parameter for the systems. So I would explain this particular notion using this a small data. So I would start by just uh, showing you this particular data. So if you analyze this data, so nothing very different to the other kind of data, where actually we have two parts. One is where we actually specify something, and another side we actually going to we have a target variable. And this particular part actually has the attribute related to something, and the second part and this second part actually something that actually we want to predict. So generally, you know that these kind of problem settings are such that there is some item, for example, there is some item X, and you want to measure few of the properties or attributes of this particular thing. So maybe here in our case it is written as x1 and x2, two properties we have actually measured. So there was some item, and for that particular item we have measured that what is the value of x1 and what is the value of x2, and let's assume the value be 1 and 9, and it was green. So let me also try to give some false uh, connection with this particular data. Let's assume that you go to a kind of Iceland where nobody is there, and you find out that there are some fruits you see that they are lying around, and you don't know that whether you should eat this particular thing or not. But you have discovered that inside, if when you cut that particular fruit inside it, either it is green or it is red. If it is red, you should not eat it, or when it is green, you should eat. Okay, or vice versa, anything could be possible. So there are two classes. So but when you are seeing that particular fruit from outside, you cannot decide that what is going to be inside. So this is a simple problem where few items are there, and you want to find out that what is the color inside. Color could be red and green, as I discussed. Color could be red and green. So what would you do? You would somehow pick a particular item and try to measure some of the attribute. So here in our case, as I'm telling that two attributes we are going to measure. Let's assume the first attribute could be what is the weight, second attribute what is the softness. Okay, maybe these kind of attributes we can measure, and softness could be on multiple scale from 1 to 50, some value, whatever it could be. Weight could also be some into the gram, what is the value. So for every item you can find out that what is the property x1 and what is the property x2. I think this should be clear, that if you pick any item you can find out that what is the property x1 and x2. And then you created a table, because if you want to learn something, you have to invest something. So initially you picked some of the items, and now they are going to be wasted only. For those items you measured what is x1 and x2 for every item, and saw inside by cutting that what is inside. So you come up, let's assume that you come up with this kind of table when x1 was 1, and when x1 was 1, x2 was 9, then inside it was green. It was 10 and 9, inside it was green. 4 and 7, it was green. 4 and 5, it was red. Let's assume that by this method you created this table. Any questions on that? Make sense? So your learning objective would be to do something to come up with some kind of understanding, so that if a new item is given to you, and again the new item would have x1 and x2. Let's say x1 is equal to 3, x2 is equal to 9. If I ask you that if there is some item which has x1 is equal to 3 and x2 is equal to 9, can you tell me that what is inside? Is it green or red? So you know that into the lazy learning setting you generally have to search for x1. Is there any x1 having the value 3? There is no x1 is equal to 3, so you cannot learn it. You cannot tell the answer in the lazy learning setting. But into the better systems, you have to do something to find out the right kind of parameters. So how can you learn this? Okay, so By seeing this data, you would think that looks like that, okay, data is into the two-dimensional only because two values are provided to me, x1 and x2. Why don't I plot all these values? Okay, the first thing would be that you would try to plot these things. So on one side you say that here it is x1, another side there is a property called x2. So x1 and x2, x1 is going to, I can see the maximum number is 10. So let's assume that here it is 10. So here it would be 5, then here it would be 2, and then it will be 1, 2, 1, 2, 3, then it is 5. Okay, 3, 4. Am I right? Am I doing wrong? Once again, let me plot it. So it's not very difficult. Okay, just for sake of x1 and x2. x1 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Similarly, what is the value of x2? It is also 10. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 1, 2, 3, 4. All right, so let me change the color and draw the lines so that I can plot the points. Okay, so here are my points. Can you tell me? So I can draw this line. Let's assume I draw this line, and look, I'm not good into this drawing business, so don't tell anybody. Okay, so let me one by one pick the green points. 1, 9. So can you help me? It is 1, 9. So this is the green point. 10, 9. So 10, 9 is 10, 9 is here. This is also green point. And then 4, 7. 4, 7. 4, 7. This is also green point. And then 8, 9. Then 8 and 9. Okay. 8 and 9. Green point. Okay. And 2, 10. 2, 10. This is also green point. 8, 5 is green. So 8, 5 is green. Am I right? All these green points are plotted. Let me plot red point also. So red is 4, 5. 4 and 5. This is red. And 4, 5 and 5, 3. 5, 3 is this red point. Then 4, 2. 4, 2 is this. Then 2, 5. 2, 5. Okay. Am I right? 7, 1. 7, 1. And then 1, 2. Then 8, 2. 8, 2. Okay, so I can draw the things in this particular way, and this is what the data I have. Make sense? This is what the data you have. So let me also remove these things for the better clarity. Okay, so what do you think about this data? When you plot this data, immediately you understand that looks like the data is linearly separable. Immediately you recognize that looks like the data is linearly separable. If you draw a line like this, or you draw the line like this, any such lines is going to work for me. Anything above on this particular line is actually green, and anything below upon any one of these lines is actually red. Make sense? Yes or no? Yes or no? On this data, you immediately recognize that this is a linearly separable data. If somehow you can find out a line, you can perform this you can perform the operation that with respect to this particular line, anything that is up is actually green, and anything that is below is going to be red. Okay, so as I told you that you have actually plotted this into the into x and x1 and with respect x1 and x2, and you have seen that a linear line is going to separate this. This linear this thing is a very interesting thing, and how can I find out this particular line is definitely going to be a good question. But for now, let's assume that somebody gives you this particular equation. For time being, let's assume that somebody gives you this particular equation, because I told you that there are multiple lines which can be good on this particular system. So somebody gave you this particular line that look, this is the equation. In this equation, if this particular value is greater than 0, then it is green, otherwise the point is red. Okay, somebody gave you this particular equation. How to find out this equation, we would come back later, but let's assume that somebody has given you this particular equation, 2x1 plus 3x2 minus 25. You find out that what is the sign of this particular quantity. If this quantity is greater than 0, then you say that the item is green, otherwise you say the item is actually red. My question is whether this formula is correct. Okay, you can just verify. Let's verify for one such example. Let's pick this particular one. Okay, 10 and 9. So what is the value of x1? X1 is equal to 10, x2 is equal to 9. We want the value of 2x1 plus 3x2 minus 25. Can anybody help me to find out this value? What is this value? What is this value? Can anybody type? Can you compute? 22? Okay. So this value is 22. Since this value is greater than 0, so I say that it is green. And you can see that here also it is green. Let me take one more example where I say that, for example, this example 7 and 1, 7x1 is equal to 7, x2 is equal to 1. Then what is the value?
-8.
-8. If it is -8 means it is red. Again, I'm right. In fact, this equation is true for all the values. Okay, this equation is true for all the values. So what we ultimately understood, that if the data is given to you, you try to visualize that particular data. It looks like that if there is if the data is literally separable, if somebody tells you that this is the equation of line, then you can find out the classification of any item. For example, for all these items, you can find out the classification, and this classification is going to the correct only. What does it mean? It means that you need not to store this particular data. Why you have stored this particular table? Because you want to store some data. What is the data? That if this is the point, if for 4 5 the value should be red. What is the purpose of this particular table? For 210 the value should be green. But if you know this equation itself, if you know this particular equation itself, then you don't need this particular table. Okay, because for if somebody comes with the value 4.2, I can put into this particular formula and immediately get this. What is the value? Why should I keep this particular value over here in this particular table? So what does it mean that this particular table, how many values we had? 1 2 3 4 5 6 7 8 9 10 11 12 13 13 value. 13 multiplied by, in every row there were 3 values, means 39 values we were storing. Instead of this, only this particular equation that have how many values? You know that x1 and x2 are specified, so only 3 values need to be specified into the equation. So instead of using this 39 values, instead of using 39 values as a table, only 3 values suffices for you, because this table can be represented using only these 3 values. Make sense? So learning, or the machine learning, or any kind of learning system, try to actually it ends up the summarization. You can understand in this way that machine learning ends up into the summarization of the things. So this table was a big thing, but we have summarized this 39 values to only 3 values. So it is a compression. Okay, a good ML algorithm would do the compression the most. If let's assume that this is the one system where you are telling that it is a linear model, linear model has compressed to three values. Let's assume there is some other model, I'm not sure about this, it compresses to 2 values only. So which model is better? That new model would be better. Okay, if any other model that actually summarizes to, for example, 10 values, so this is also a good learning model, because 39 values are summarized to 10. But with this respect, if you compare that particular model and this particular model, you can say that this new one is going to be the better, because it has actually done the more compression to the data. So ultimate objective of any of the learning example is to do the compression or the minimization of the data. Okay, so if this is my understanding, then I can say that this particular equation represent my data, complete data. What does it mean? That if somebody gives me any other data, for example, somebody gives me a data, a new data item, and that has the value, for example, 2 3. Okay, x1 is equal to 2, one minute, new data item where x1 is equal to 2 and x2 is equal to 3, then can you tell me that what is the classification of that particular item? I would put into this particular equation, I can say that 2 multiplied by 2. So I should not take 2 3, let me take 3 2, 3 2. Okay, so x1 is equal to 3, so I would put here 3 plus 3 multiplied by 2 minus 25. It comes out to be some negative value. Okay, negative value. So ultimately you can find out that what is the classification of an item that has the x1 and x2 is equal to 2 3 as red. Okay, if you understand this, so for can I say like this, that this value, that is 3, is multiplied by something called 2, and this value is multiplied by something that is called 3, and then there is some other value, this particular part, that is minus 25, and you are going to find out the summation of all these quantities. You are going to find out that what is the multiplication of 3 into 2, 2 into 3, and then you subtract this particular value, and out of that what is going to come, you are going to see that what is the sign of that particular quantity. Once again, for any new item, if you want to find out that what is the classification of that particular thing based on your data, so we have come to the understanding that my data is represented by this particular equation, and this particular equation can be represented by this particular way. I say that the first value is multiplied by 2, second value is multiplied by 3, and then you are going to add this particular quantity, that is minus 25, and you take the term by term multiplication and you find out that what is the sign over there. So whether this representation is fine, yes or no? Instead of telling that I am going to put this thing into this equation, if I draw this kind of circuit, will this also be fine? If I remove this particular part, if I draw this kind of circuit, will this would also be fine to you? Yes. So the same thing is actually drawn here. The same thing is actually drawn over here. Same thing actually drawn over here. This is another kind of this is the same kind of diagram. So if I ask you that how you see this particular thing, if I draw something like this, how you see this? You see this as an equation, yes or no? If I draw this kind of circuit, if I draw a kind of this kind of diagram, then how you realize it, how you understand this? You understand this as a linear equation, yes or no? I need yes from everybody if you understood this particular part. Yes. Who is not understood? He's not writing yes. Anybody have confusion? Once again, last time I am going to tell, this particular representation, this particular diagram, this particular sketch is representing what? A linear equation. Okay, this is given a name also. This kind of thing is given a name also, and the name is called perceptron. The name is called the perceptron. Okay, so now if I ask you that what is perceptron, what would you tell to me? Perceptron is a linear decision boundary, because what is this? This is the linear equation of a line. So perceptron is a linear decision boundary that can be utilized whether the item is on one side or other side, and therefore you can utilize it for the for doing a kind of classification also. Make sense? For a given data, if I ask you that can you give me a perceptron, so what does it mean? It's a fancy way of saying the same thing, that can you give me an equation of a line that separates this particular data. Make sense? Okay. So it, as we have discussed, that perceptron provides a graphical way to represent the linear decision boundary. And if you have a perceptron, if you have a perceptron, so one side you would be representing all the attributes that are going to be fed to the system, and on the connections you are going to mention that what is their strength. Here you can tell them strength. However, you can, earlier you were telling that they are weights. Strengths are weights, and then this the term which actually does not have any uh, which does not need any multiplication of any attribute. We have already told into the previous classes that we assume that it has x0 is equal to 1. So here we also assume that x1 is x0 is multiplied and the value of x0 is equal to 1. So here these are the weights. These are the parameters, are the weights of what? Perceptron. These are the parameter or weights of a perceptron. At the end we want to see that what is the sign, and inside there is a term by term multiplication and the summation. How to find out this weight is an important problem, because as you know that this would be with respect to the data only. If I give you a data, if I provide you a data, given a data, if I provide you a data, if I provide you a data and ask that can you give me that what are the right parameter, what are the right parameters. So this is an important problem. Okay, this is an important problem, and many of the time we want to solve this particular problem. Once again, given a data means what? That this kind of information is given to you, that on what point the item is positive and negative. Your objective would be to find out a perceptron, means a linear decision boundary, and linear decision boundary means you want to find out these parameters. Any questions on that? So what question remains? The question remains, sir, how to find out this thing? How to find out the parameter? Okay, here also when I was telling the thing, I told you that somebody has given you. Okay, I told you that somebody has given you the what are the weights. Okay, here also I told you that somebody has given you the weights. This equation. So how to find out this weight is an important thing that we are going to see next. Any question till now? If you have any question, please ask. Everything is clear? Yes or no? Yes. Okay. Okay, so now I want to find out the right parameter. My question is this, that a database of this particular kind is given to me, and I want to find out that what is the right parameter for that particular database. Okay. Okay. So again, we have a perceptron, and if we want that perceptron to learn, I am going to tell you a procedure or the algorithm that you are going to execute to find out the right parameters. This particular algorithm is called perceptron training rule. Once again, if I ask you that how can you find out the right parameter, so you can find out the right parameter using what? Perceptron training rule. Okay. It is not like that this is only the single algorithm, but we are going to talk about the perceptron training rule that is going to give you the right parameters. Okay. And the algorithm is very simple. Algorithm says that you begin with the random weights. So once again, with respect to this problem, let me formulate this particular problem. So here, with respect to the x, we have two values, x1 and x2. So linear equation is going to be something like that. For example, w0 plus w1 x1 plus w2 x2 is greater than 0. We want to say something like that. Linear equation is going to be this, is equal to 0. Then if it is equal to 0, we want to see that which side we are. Whether this is clear? We want to find out what is the value of w0, w1 and w2. And if I ask you, just say for the completeness, that what is the value of w0, w1 and w2 in this particular case, can anybody type that what is the value of w0 here? Minus 25. Okay, it is minus 25. What is w1? It is 2. And what is w2? It is 3. Make sense? Okay. So we want write W's. So the algorithm is telling that you take W0, W1 and W2, any random values. So I don't know what value I can get. So let's assume that I get this value W0 is equal to 2, W0 is equal to 2, W1 is equal to 5 and W2 is equal to 8. Let's assume I take this value. Then what is my equation? It is 5x1 plus 8x2 plus 2 is equal to 0. This is what my equation is. Okay. If this is my equation, then I can apply this thing on my data also. Okay. Okay. 1 minute. So I can apply this on my data also. Where is my data? Here is my data. So this is what my equation is. So can you tell me that what is the, let us pick some point. For example, this, let me pick this particular point. On this point, what should be the classification? What is the classification given by this particular equation? Can you tell me? What is the classification given by my equation? So 2, 5. So you know that all these values are positive only. So you can see that all the coefficients are positive, and this is also 2, this is also 5. So it is going to be positive only. So the value that I'm going to get is only green. Okay, I'm going to get the green. If I ask you that what is the value going to be on 1, 9, so you can by yourself again see that since 1 and 9 are also positive, all these coefficients are positive, so it is going to tell what? Green. Okay, but accidentally what happens, this becomes correct and this becomes wrong. So even if whatever equation you have, you can apply that equation on your data. Whatever equation you have, you can apply this on the data, and by this you can find out that what is the classification given by my model. This is what my model is, linear model that I'm currently having. So it may be possible accidentally something could be correct. Okay, even if it is not trained, something could be correct. So here I'm correct, here I'm right, but here I'm wrong. So maybe some places, for example, are in this particular example, and all the places you are going to be the wrong, and here into the green one you are going to be the correct. This is going to happen. Make sense? So how many places I'm wrong? 1, 2, 3, 4, 5, 6, 7. 7 places I'm going to wrong. And out of 13, so 5 places I'm going, there are 13 places, so 6 places I'm going to be correct. 6 places I'm going to be correct. 7 places I'm going to be wrong. Okay. The algorithm says, let us go to the algorithm. Randomly select the weights. So I have selected this particular weight. That's why I got this particular equation. And then it says for each misclassified examples, you perform this kind of update rule. What is this update rule? It says that weight 1 is equal to weight 1 plus eta. What is eta? Eta is some system parameter that is a constant into target minus output. What is target? Means what I wanted and what I got. So in this particular case, since there were green and red, so how can I can say something about green and red? How can I subtract green and red each other? So most of the time, what happens now? We can convert this problem to the numerical one by having what? Let me say that green is equal to +1 and red is equal to -1. Okay, so it is a two-class classification problem where +1 and -1 I'm going to get. So green versus red. Okay. What is where I was wrong? I was wrong in this particular case. What was my target? Was my target? What I wanted? Target was -1. Target was -1. What is the output of my model? Few minutes back we have seen that my model was giving what? Positive means +1. So I want the value for target minus output. Target minus output is equal to -1 minus 1. This particular quantity na -1 is equal to -2. So target minus output is -2. Using this particular value -2, so I say that target minus output is equal to -2. Then I multiplied with the value of x. Means for whatever example I was considering when I was considering this thing. So I would, if I'm modifying x, so you know also that there is x0 where all the values are 1. If I was modifying w1, At that time I would use this particular value 4 multiplied by what, 4 multiplied by 2 multiplied by eta, and I use this particular value. You understand? Eta is equal to 0.1, for example, t minus 1 is minus 2, and this x was 4. Whatever the value of, what was the value of w1, let's assume that I'm updating w1. W1 is equal to 5. It is 5 is equal to 5 plus this particular thing. Do you understand? So if I do this, the value of new, by this I'm going to get the new value of w's. So everybody understand this, how I updated the value of w? Yes or no? Yes? Okay, great. Please focus. If you have any confusion, please ask the thing. Okay, that's very important. So I told you that out of my databases, 7 points were actually problematic. So for each of them, I am going to change. For each of them, I am going to change the value of this. For each of the data items, I am going to change the value of w's. So after one iteration, I would again come here and again do the misclassified one. Okay, for every data item I have actually modified this, and then I would again do this change until my number of misclassified examples becomes 0. Until my number of misclassified example becomes 0. Whether the procedure is clear? Okay. Please note that I am going to modify this for the misclassified example. You can ask some questions like that, whether what is the guarantee that this is going to converge. So we would come back to this very soon. Okay. So few lectures back we have seen that there was some other method to modify the weights. Do you remember that? What was that? Wi is equal to wi plus wi is equal to wi plus alpha time yi xi. Some kind of this kind of rules we have earlier seen. So I'm just writing to so that it comes in front of you. So later we would utilize it. Okay. So I am telling that for the misclassified examples, I am going to do this. What is the misclassified things? Let's see that what is the target. Okay. In the misclassified cases, what is my target? So let's assume the target is +1. If the target is +1 and the item is misclassified, then what is the output of my model? What is the output? Can you tell me? If the item is misclassified, what is the output? Is it +1? No. If it is the item is +1, then it is rightly classified by my model. Na? This is my model. My model is giving me the output. Okay. If the item is positive, my system for the misclassified one, misclassified example, my output would be -1. Okay. If the target is -1, then the misclassification, my output of my system is going to be +1. This part is clear to everybody. Okay. What is target minus output? Because I'm multiplying with target minus output. So can you tell me what is target minus output? So target minus output in this particular case, can you tell me what is the target is +1 minus output means -1 is becomes 2. This value becomes what? This value becomes 2. Similarly, into the second case, target is -1 minus +1 is equal to becomes what? It is -2. Make sense? It is target minus output is equal to -2. Okay. So in this case, can I write like the equation like this? But that this particular equation is Wi is equal to Wi target minus output is 2. Okay. Plus eta time 2 multiplied by xi. Can I write like this? And here I can write Wi is equal to Wi plus Wi minus eta time 2xi. Am I right? Can I write like this? Yes or no? You need not to write yes, you just put y. So all the students, can you write yes or no? Okay. This is like this. Okay, great. I am going to introduce something more. What is the value of, and you know that what is target? In the previous setting, we were telling it xi, yi. Okay. What is the value of yi? So if I multiply yi here, is there any problem? Because what is the value of yi? It is +1. Can I multiply? Okay. So here it is -1. So if in this equation I also if I multiply by yi, then I can remove this negative part. Na? I can remove this particular negative part. Makes sense? Because yi itself is negative. So can I write like this? Yes. So if in both the cases the equation is same, then the equation looks same. So I can remove this particular part. I can say that the equation is this. 1 minute. I can say that equation. This is what the equation I am going to modify. Make sense? So here also one thing I can do. Why 2 eta? Instead of 2 eta, can I write alpha? If yes, then I can write this equation wi is equal to wi plus alpha time yi xi. It is just a kind of rearrangement. Okay. It is just kind of rearrangement. So you can see that the formula that actually I have written over here is the same formula that we have talked about earlier. And we have seen that if the data is linearly separable, this kind of formula can always give you the right kind of convergence. In the previous sessions, in the lecture number 3, we have seen that this formula can give you the convergence into a finite amount of time, finite number of steps, this if the data is linearly separable. Agree? Yes or no? Ready? Okay. So then you can ask, sir, then why we have written this kind of complex thing? Why target minus output we have written? So let me tell you that why we have written. The important is this, that what is the t minus o? In case when the things are right, when the item was positive, my system was telling positive. When the item was negative, my system was telling negative. At that time, target minus output becomes 0. T minus o becomes what? 0. So if I use this formula for all the data, then also it is fine. By writing this, what advantage I have, that I can apply this formula on all the data. So I can say that instead of misclassified example, on the complete database you apply this particular formula. There is no problem on that. Make sense? Yes. So this is what the equation it is. This particular way is called the Perceptron training rule. That is very simplified formula that you have seen earlier also. And we have seen that this particular, because I would not go into much into the detail, and by yourself you can fill into the dots, that in case in case of the misclassification, when the item was positive and my system was telling negative, then what is going to happen? The item was positive, my system was telling negative, and at that time the target, this was the target, this was the output, then the target minus output was +2, means what? My weights are going to increase. And when the item was negative, my system was telling positive. At that time, my weights are going to reduce. Target minus output is equal to -2. Then my weights are going to reduce. If my weights are going to reduce, what does it mean? That this is what my equation, na? W0 plus W1 x1 plus W2 x2. If let's consider this particular case, when misclassification was there, and I have actually applied this particular formula. In this case, my weights are going to increase. So if the weight are going to increase, then what would be the new summation? If this is, because earlier I was using this formula, but now I would increase these weights, and then the new formula would give something that is whatever I am going to earlier getting plus something delta, it is going to give me something more. If it is going to be giving more, and right now what is the value that this system is giving? This system is giving negative value, and you are adding something. Then adding something means what? If a negative value you have -5 and you are adding something that is going to be positive, we are adding positive something to it. So from -5 it becomes -3, then after that it becomes -1, then after some time it would becomes 2. So if you are adding something, means you are bringing the system from negative direction to the positive direction. What happens into the other case, into the next case, when actually the item is actually negative and your system is going to still positive? We have seen that the weight is going to reduce. If the weight is going to reduce, then whatever you are going to get, whatever you are going to you were getting earlier, now you are going to get something lesser than this. Means this value is going to be reduced. You are going to tell that this value is minus delta, something is less there. And in the scenario, why you were telling positive? Why you were telling positive? Because your summation may be 7. For example, your answer may be 7. That's why you are telling positive. But by this update, your value is going to reduce. We have seen that value is going to reduce. Then what would happen? It may become 3, then it becomes 1, then becomes -2, and if you ultimately if you get reduced, then it becomes negative value, and therefore your answer would be correct. This is what the basis behind this. So we have discussed that why this would converge. We have seen the proof in the previous class that weight changes when the how the weights are changing, and we have actually discussed all these things. Okay, so please note that the data is linearly separable, then only this kind of methods are going to work. Let us apply our method on the data. Okay, this was the data that I had now. This was the data I had. So let me apply this on the data. And this is a real example that we have actually executed, and you are also very good into that. You can just in a very few minutes you can write the code, because it's a very simple update rule. You can create this data, you can populate an array, and in that array you put these values and just execute the code. You can 5 minutes you can write this particular code. And let me start by having the random weights. So initially the weights are random. Okay, 0.5, 0.5, W1 is equal to 0.5, W2 equal to 0.5. So if this is the thing, then the equation would be something W0 plus W1x1 plus W2x2. It becomes 0.5 plus 0.5x1 plus 0.5x2. This is the equation. Everything is positive. So it is going to tell all the items as a positive. So places where there is red, they are going to be misclassified. How many of them? They are 7. So number of error is going to be 7. But as I told you that this equation we are going to utilize to change these values. So if you apply this 7 number of time, 7 time values are going to change, and then what they become? W0 0.36. Okay, this is changed. The value become changed to this 360, then minus 0.12, then 0.1. These values changes like this, and when you again evaluate, the error becomes on the 6 point. Any problem in this? Do you understand all these things? Yes or no? Please tell me, do you understand this thing? Yes or no? So initially the error was on the 7 points, and then after that it falls to the 6 points. Then you again updated this, you are going to again update the thing, and now your error goes to 5 number of points. So 5 points error. Okay, the error goes to 5 number of points. Again you update, the error comes to the 4 number of points. Again you update, you can see that the error has increased now. Very interesting thing, that error has increased. Sometimes it happens because line changes, then the number of error actually increased to 5. Again you updated, error becomes 4. Again you updated, error becomes 5. You can see that there is a fluctuation. Again you 2, error becomes 4. Again you update, error becomes 5. Again you update, error becomes 4. Again you update, error becomes 5. Again you update, error becomes 3. Oh, very good. It has at least reduced something. Again you update, error becomes 4. Again update, it becomes 3. Then it remains at the 3. Then 2. Very good. Then again 2. So I'm not showing all the iterations, 14 iterations I have just eaten up. After some time you got one error. So after some time you got to the one error. Then after that 2 errors. Again you increase to the 2 errors. Then 2 errors. Then you stay on the 2 errors. Then 3 errors. Then again there is 3 errors. And then 2, 2, and suddenly it becomes 0. Then it comes to 2. Am I right? 2, 2, 2, and it becomes 0. 0. This is what your learning curve is. So I think I have. So this is how your error is going to reduce. Make sense? Yes or no? Okay. Let us see it pictorially. Initially, these were the data points. These were the data points when the value was 0.5. First equation was 0.5 plus 0.5 x1 plus 0.5 x2. So on one side there is x1 and the side there is x2. The line would be something like this. So all the points above are actually positive. So all these points which were red point, they are getting misclassified. So number of error is on the 7. Immediately when you updated the thing, the line becomes this. Okay, so these were the misclassified ones. These were the misclassified ones. Again, when you update, the line becomes this. So these were the misclassified ones. When you update it again, these were the misclassified 4 points, then 5 points. These were the 5 points. You see how the line is changing. You see the 4 point, again error on the 5 point. You can see. Can you see? Now the line is this. Now the line is with the 2 point error. These were the errors. Again, you can see the 3 point error. This is again 1 point error. Error on 1 point, error on 2 point, and this is the final point. This is the final equation. You know that this could be a better line that you can, as for example, SVM can give you better line. But right now we are not interested in that. Our training has given some line that has a 100% accuracy, means all the points are correctly classified. The issue with this kind of strategy is only this, that convergence is not gradual. Okay, convergence, we have seen that sometime it is increasing, sometime it is decreasing. So what may happen into the real life scenario, your data would not be like this where the things are actually linearly separable. They would not be linearly separable. So for example, if I say that there is one red point here and there is one green point here, so you cannot do better than this, that even the same line is going to be the better one. You can start with the 2 when you get the 2 number of error. But if you see this particular table, on this particular table, you know that if you see every time things are going to be up and down, so you don't know that where to stop. When the value would be 2, then you should stop when the value becomes 2. But you don't know that whether 2 is the right thing when you should stop. In this case, we know that when the error would become 0, then I would stop, because sometimes it is coming up, sometimes coming down. So I know that ultimately it would come to 0 because data is linearly separable. Then I would stop. But in other cases, when actually data is not linearly separable, we are not sure when to stop. Okay, this is the biggest problem with this kind of training strategy. And how can we solve this? We would talk into the later classes. But you try to understand that this is the biggest problem. Anybody have any issues with that? Is this a problem or not? Generally, what we expect, that when we keep training with respect to the time, error is going to reduce like this. Okay, so generally the training error reduces like this. So what happens that there is a test called elbow test, that actually you can see that here the gradient is very high, and after some time the gradient becomes very less, even if there is increase, but very less increase there is. So this is the point where these two lines are going to meet. So we can say that we are going to stop somewhere here. This is the elbow test. Many of the time people talk about this elbow test. We say that after this time we are not going to train, and this is whatever the things I'm going to utilize it. But in this case, we don't know that where to stop, because if I'm going to use this kind of training strategy, my curve is not like this. My curve would be like this. So I don't know that where to stop. Makes sense? Whether it is going to touch the 0 point somewhere or not, I'm not sure about this. This is the biggest problem with this kind of a strategy. However, this strategy, as we have seen, that it guarantees, mathematically guarantees that after finitely many steps, if the data is linearly separable, we would able to discover the correct line that divides our line. That's all for today.